Okay, guys, in this case, instead of enolate, we're going to use a different nucleophile, and the nucleophile is going to be an enamine, okay? Nucleophile, enamine. We already have learned how to make enamines. If you have a secondary amine, by reacting with the carbonyl compound, it's going to give you the enamine with the double bond on the more substituted position. So let's just pick up an enamine of our choice. And react it with the enone. Let's take a look at the outcomes of this reaction. What will happen in this case, the lone pair of electrons on nitrogen is going to come on the bond between carbon and nitrogen, resonate, and attack the electrophilic carbon on enone. Electron density will move around and be placed on the oxygen. We understand that if the metal group is on the bottom, the attack will happen from the top. Let's put together the product of the reaction. Intermediate, actually. Nitrogen will get a positive charge, okay? And actually, here, let's be a little bit more elegant. I'm going to send the two metal groups on nucleophilic position down, so it doesn't interfere with the rest of the molecule.
Mrs. O, shouldn't you start with a secondary amine?
We are not starting with amine, we're starting with enamine already. And enamine is produced with the secondary amine reaction with the carbonyl compounds. Ketone.
Oh, okay. All right, thank you.
Thank you. So, and now this is our new bond. Let's just put the new bond in different colors so it will be visible for you. And let's put the rest of the molecule. We will take care of stereochemistry later. For now, that's not the most important part. Did I move my, oops, I did move my carbon. See what happens when you don't pay attention. Okay. Here we are. So the electron density is going to come back from carbonyl oxygen, move onto the gamma carbon. Okay. And this reaction is actually done under acidic conditions. Okay. So we are going to abstract a proton from the source of acid. And form this product. It is still intermediate. My nitrogen is carrying a positive charge, okay? So we will come back to stereochemistry. Don't worry about this. The reaction was done under acidic conditions, as I mentioned. So now we're going to recover the neutral position on the nitrogen, and we will actually recover the carbonyl there. So at this point, the water molecule will attack the carbon carrying nitrogen. Electron density will move onto the nitrogen. Oxygen carries a positive charge. We're going to perform a quick proton shift. The proton will move from the oxygen onto the nitrogen. Making this group a good living group. We will be ready to kick it out. Almost reformed our carbonyl. Okay, and finally, last step, water molecule will pick up that proton. And we're done. If we were just given this product only, we would never be able to recognize that we did start with the enamine because we got rid of the nitrogen altogether. Before we leave this page, let's make sure that we take care of stereochemistry. Going back to the starting material, our metal group was pointing down, so the attack would be done from the top. We can just put a wedge over here, and let's recover the dash on this position. And this is the product of the reaction. Now, if indeed you're given your enamine, then you're going to proceed with the reaction, identifying the alpha position next to the carbon to nitrogen bond. You recognize this alpha position, and you move the reaction mechanism, your prediction of the product, all the way to formation of Michael adduct. And then instead of carbon to nitrogen bond, you recover the carbonyl there. Okay. So this is a good reminder of chapter 18, formation of enamines, and also the hydrolysis of enamines back into a carbonyl ketone or an aldehyde. And finally, the very last reaction, and I'm going to see if I do have that reaction somewhere in my slides, is the Robinson annulation reaction. It's again an extension of Michael addition reaction. So let me see if I do have that slide. Just a quick second. Robinson's annulation reaction. So I'm going to just pick up the starting materials, and the product, and we will go over the mechanism together. Okay. See, since you're given that in your lecture notes, I want to make sure that we go through that example together. Okay, so Robinson's annulation reaction is the result of